Well there, what have we got? Oh my goodness, pollen grains. Pictures taken with an electron microscope that have been computer enhanced as far as the color part. But wow, they look different. And yes, a pollen expert can just look at those pollen grains and tell you what kind of plant they came from. And I'm a pollen expert. Let me look here. Let's see, to the upper left we have, it's grass pollen. And to the upper right, let's see, that is rose pollen. And the pollen at the bottom, let's see, that is ragweed. So grass to the upper left, rose to the upper right, and at the bottom ragweed pollen. And so I can tell you that because not only am I a pollen expert, I can also read the caption at the bottom of this picture. Oh my goodness. Oh, you say, well, okay, Professor, we get it. Anyway, what are we actually looking at? You're looking at the outer shell of pollen grains, a very tough substance, very resistant to decay and many other things. And as a matter of fact, the most abundant fossil in the fossil record is fossil pollen and spores. There's lots of rocks that are just full of pollen and spores, and some people, as part of their research, some scientists actually get pollen out of rocks. How do they do that? Well, they get the rock, a chunk of the rock they're interested in, they grind it to powder, and they mix that powder with nitric acid, a very, very strong acid, and the nitric acid completely dissolves the rock matrix. It doesn't touch this hard outer coat of pollen grains or spores. And so then there's several more steps in the processing, and at the end you have a microscope slide with a sampling of the pollen that was in that rock. And so what can you tell by studying the pollen that was trapped in a rock for quite a few years? What can you tell? Well, if you're truly a pollen expert, you look at that pollen and you can figure out what types of plants were growing at the time the rock was formed. So that's what some people do. Now, we are primarily going to be interested in what's going on inside the pollen grain, not around the outside. But as part of the drawings we'll see in the quote-unquote pollen story, I'll put a little kind of spiky exterior to the pollen grain, kind of reminiscent of what we see here in these ragweed pollen grains. Now, where's pollen formed? It's formed in an anther. This happens to be a lily anther. And at least this part around the outside of the anther, what's this right here? That's the filament. That's the filament. So this is a lily anther. It has how many sacs? 4 sacs. And inside each sac, that's where pollen grains are formed. Many hundreds or thousands of pollen grains are formed inside these pollen sacs. And so what we're going to do as we discuss the pollen story is we're going to look at just what's going on with pollen development at this point. And everything that occurs will occur inside from beginning to end. Everything we're going to look at in the pollen story, at least this initial chapter in the pollen story, occurs inside one of these sacs from beginning to end. And so what we're actually going to do, this is a picture from your textbook, we're not going to do an entire life cycle here like we did for the animal kingdom and Basidiomycetes. We're going to actually dissect out part of the life cycle, this part up here to the upper right here, the part that involves anthers and pollen grains. We're going to kind of take that little part out and treat it separately for right now. And so here we are with an anther. It's got its 4 pollen sacs, pollen grains form in each one. And before we move on with the pollen story, let's notice a couple things about this anther and the tissue that it's made of. Of course, it's made of cells, right? You can see a lot of cells, lots of cells. And what are these little red things inside the cells? Red things. Those are nuclei. You might be thinking, well, how come I don't see nuclei in every cell? How come some have them and some don't? Well, that's real simple. The cells have depth. The knife that comes through using a special device called a microtome makes very thin slices. And the nucleus may be back here in a cell, and a number of the slices may just miss the nucleus. It doesn't make the cut, so to speak. So But as we go through the pollen story, I want you to keep track of chromosome numbers. And so let's start right here. Let's start right here. These nuclei we see in this picture right here that are part of the anther and of course part of the filament as well. What is the chromosome number of these nuclei that make up the anther tissue? The chromosome number of these nuclei is 2n, whatever 2n is for that particular species. What's the chromosome number of anther cells again? 2n. 2n. All right. Without further ado then, we'll end this video and get ready to start the pollen story proper. All right. Bye-bye.